start with part 3 of the chapter circles, ninth standard. Okay, it covers both CBSE ninth chapter and the state syllabus 12th chapter. Let's start this session with the revision of the one of the concept which I explained in my last class. The one is subtended angle. Okay, take a line segment PQ and take one more point R. Make sure this point is not on the line PQ, it's outside. Okay, then join PR and QR. These joins are okay. So it looks like a triangle. And this arrangement, the arrangement of lines creates an angle. Okay, let's call it as alpha. Okay, at the point R. So this angle is of my interest in this class. Okay. Okay, look at the definition also, look at it here. Sub is a prefix, which I can call it as under or beneath. Okay, so under what? Under the point R or beneath the point R. You can say that. So tend here is what? Extend or aim or stretch. Basically, think of it. This line is PQ line is getting extended like this and making an angle R. We can summarize like that, or it's being aimed at point R, right? So that's how the word subtended angle, being coined. Okay. Coming to the exact, the topics what we are discussing, right? So observe this point. Angle PRQ. So this angle PRQ. Okay, PRQ. This creates an angle theta. Okay, I can call this theta as an angle subtended by the line segment PQ. Angle or angle theta is an angle subtended by the line PQ, at the point R. That's how I can call this. And in the simplest word, in the simple words, I can call this subtended angle. This is a angle theta. This is a subtended angle of line segment PQ. Okay. Okay. Now imagine the similar structure of lines inside a circle. Okay. Now what is this PQ? I can call PQ as a chord. Okay. And what is this? R and S are the 2 points on the circumference of the circle. And O is the center of the circle. Now look at join all the lines, all the points, PO and OQ. Observe there is an angle formed here at the center. From the point, from the line PQ. Okay. I call this line, I call this angle as alpha. Okay. Angle alpha or angle POQ is called the angle subtended by the chord PQ. Okay, at the center O. Okay, na? So angle POQ is the angle subtended by the chord PQ at the center. Similarly, we have other angles. Okay, like PRQ. PRQ is an angle subtended by PQ at the R. Similarly, angle PSQ is an angle subtended by the chord PQ at point S. So this is a concept of subtended angles which we are going to use again and again in the remaining part of our class. So this point to be remembered. Now let's get into theorems and circles. Okay, the first theorem, theorem 9.1. So the 9 stands for the 9th chapter. Otherwise, the first theorem on circles. Okay, what it says is equal chords of a circle subtend equal angles at the center. It means equal chords subtend equal angles at the center. Okay, let's get into a little bit more here. Okay. Okay. So what are things we typically consider when we talk about theorems, right? We talk about data, what is given as part of the theorem, as stated in the theorem, and what is required to prove it, okay, and how to prove it. It's a proof, real proof, right? These are the 3 things which we consider. Let's go one by one on this theorem. Okay. Okay, let's imagine it. Let's visualize this theorem first. What is this talking about? It is talking about equal cards here. Correct. It's talking about equal cards. So then I have to come up with a diagram which has equal cards. So this is a circle. This is a circle. It has got equal cards. What are those equal cards? A, B, and C, D. Okay. So let's see. Okay. Yeah. Before that, let's talk about the basics of basic parts of this circle, which I'm going to use. What is the center of the circle? Clear? Okay. So next, A, B, and C, D are cards. A, B, this part, A, B, this part, and this part. They are cards of this circle. Two cards. Okay. Next, AB is equal to CD because they given that theorem states that equal cards of a circle. So AB is equal to CD, equal cards. It's given to you, right? So then we have angle AOB. Yeah, I told you in the previous slide. I was talking about angle AOB is a separated angle of the card AB. So AOB, angle AOB, this one, right? This one, angle AOB is the separated angle of the card AB. Similarly, angle COD, this card, this angle is a subtended angle of the card CD. Remember, the subtended angles are at the center. Okay, so these are given. Now, what we need to prove? Let's understand. We need to prove that the subtended angles, right, AOB and COD angles are equal. They subtend equal angles at the center. We have to prove that. Okay. We have to prove angle AOB is equal to angle COD. This is an important part of it. This is our aim of this, subject of our proof. Okay, let's see how it goes. Okay, now let's remove all these drawings. Okay, right. So let's take a red colored one. Now in triangle COP, see now in the circle, if you see the image, we have two triangles are formed. Okay, we have a AB and CD, which are cards. I joined A and B and C and D all to the center. This makes a triangle 1 and triangle 2. Okay, let's consider triangle 1 and 2 separately, like this. Okay, and triangle AOB is the left one, triangle COD is the right one. COD. Okay, so then observe this in this diagram. OA is equal to OC. This OA is equal to OC. This OA is equal to OC, this one, right? Because what are those? Why they are equal? Because both of them are, OA is the radius of circle. Similarly, OC is also a radius of the circle, right? So they are equal. Then observe other edges of this triangle. This OB is equal to OD. Why? Because both of them are edges, radius of this circle. Okay, so naturally they are also equal, right? So let's go for the third one. AB is equal to CD. Why AB is equal to CD? This AB, this card AB is equal to CD. Why it is CD? Because it is given here. Look at it. It's part of the theorem. It's equal cards. AB is equal to CD. It's given in the part of the theorem. So naturally AB is equal to CD. Correct. Observe this. What is OA? These are all sides of a triangle. Correct. What is OB is equal to OD? These are sides of the triangle. What is AB is equal to CD? This is also a side of the triangle. Observe. All three sides are equal among the two triangles. This is what we proved as first step. Like, yeah, let's conclude next. Then, so now because all three edges of the two circles, it means like the corresponding the three edges of the left circle is or equal to the corresponding three sides of the other triangle, we therefore conclude that triangle AOB, this triangle, okay, is congruent. This took angle triangle COD. So this triangle is congruent to this triangle. One and two are triangles are congruent. That's what we conclude. Question now is why we are able to conclude this. That's we'll see. Because of the congruency of the triangles that we are going to study in a other chapter on triangles, right? But what is the takeaway is, since what we proved now is these two triangles are congruent, And the congruency rule is yes, yes, yes. It means side, side, side rule. We prove that all the three sides of one triangle are equal to the corresponding three sides of the other triangle. Okay, and this proves that, but by this S congruency rule, we prove that triangle AOB is triangle AOB is congruent to the triangle COD. Now let's take one more concept. Yeah, before that, before we go to the next topic, let's understand what is the SSS rule. It says, look at this diagram itself. This is 3.5. These are two triangles. Remember, one side is 3.5 centimeter. Look at here. This is 3.5 centimeter. So that both are equal. Let's take other thing, 4.5 centimeter. Here is 4.5 centimeter. Second edges are two edges. Second edge of two triangles are equal. Then let's say third edges of it or side of it. Look at third side of it. So it means this is equal to this, right? So it means what we proved is the three sides of one triangle are equal to the corresponding three sides of the second triangle. So we proved they are congruent. Okay, this is explanation of triple S row here. Okay, next go to the next step. Then because those two triangles are congruent, we know that by concept, okay, angle AOB is equal to angle COD. Angle AOB means what is that angle? Angle AOB. What is angle AOB? Okay, angle AOB, this angle AOB is equal to angle. Why? That is from this formula CPCT. What is simple CT? Let's go to the next one. So in the you see, when now we proved that the triangles are congruent, right? So within the congruent triangles, the corresponding parts are equal. It means corresponding edges are equal. At the same time, corresponding angles are also equal. Now we proved corresponding edges are equal. We conclude that corresponding angles are also equal. What are the corresponding angles? Is angle AOB and angle COD are corresponding angles, and then we prove that angle AOB is equal to angle COD by the property of CPCT. What is CPCT? Corresponding parts of congruent triangles. Corresponding parts of congruent triangles. That's so using the property of the triangles, congruency rules, we prove that equal chords AB and CD subtend equal angles at the center. That is AOB and COD. This is a proof of it. Now let's take a small quiz on the theorem number 1. Okay. The question is simple. If two chords of a circle subtend equal angles, we proved, right? We two equal chords subtend equal angles. Now I'm asking you the question in the opposite direction. If two chords of a circle subtend equal angles, if the angles are equal at the center, what do you say about chords? In the last slide we proved equal chords subtend equal angles. Now the corollary now I'm asking now is, if angles subtended at the center are equal, are the chords equal? Is the question now. Are they Cauchy equation? Let's see the answer. Are they equal? Answer is yes. It's simply a corollary of it. Just to visualize it, I added a couple of slides here. So the chords are equal, angles are equal. If angles are equal, chords are equal. If chords are equal, angles are equal. As simple as that, right? Similarly, I just added even more information to say that I give you additional information that arcs are also equal if chords are equal. Right. Okay, let's start to the next theorem, which is 9.2, second theorem of the circles. What it states is, if the angles subtended by the chords of a circle at the center are equal, it means if subtended angles are equal, then chords are equal. How do you say that? If the subtended angles at the center are equal, then chords are equal. Okay, let's see what is this about. See, observe this point here. this is very similar to what is the second quiz I asked you, right? So it means this is very similar to the theorem 1 also, right? Okay, so we call this as a converse of, we can refer to this theorem as a converse of the theorem number 1. Theorem number 1 talks about equal chords subtending equal angles. This theorem talks about equal, if chords subtend equal angles at the center, then they are equal. They're converse of it. Okay. Theorem 2 is a converse of theorem 1. But as usual, we start with data on what to prove and actual proof. Okay. So visualization. First of all, we need to start with visualization and giving visualizing the theorem. Now, what this theorem says is, if, so angles subtended by the chords AB and CD are equal. It means this angle say alpha, this angle say beta are equal. It means angle AOB is equal to angle COD is given. Now let's see what is that. Okay. Okay. What is that given? Yeah, I mean, let's take AB and CD are chords. Okay, na? A, B, and CD are chords. Okay, we drawn it. We don't know the length of it. We just drawn the two chords A, B, and CD. Okay, we know for sure they're chords, but we don't know the length of the chords. Then see, this chord is subtending an angle AOB at the center. So that angle AOB is subtended angle of AB. Angle AOB is subtended by AB. Similarly, angle COD is subtended by chord CD. This is clear, right? Right. This is clear. Next, go to the next one. Then, what is one more thing given is that what is one more thing in the theorem is there are equal, subtended angles are equal. It means this angle is equal to this angle. So I'm writing it. Angle angle AOB is equal to angle COD. Clear. This is given. Then let's understand what is that we need to prove it. Now we have to prove what? AB is equal to this chord is equal to this chord. Because these two chords are subtending equal angles at the center. So you have to prove that AB is equal to CD. Two chords are equal. AB is equal to CD. Which are two chords, remember. Okay. So we know now what to prove. Let's get into the proof. Okay. Okay. In figure 1, left side one. Okay. Let's me clear all the the drawings. Okay. Right. In the in the figure 1, what's happening? OA is equal to OD. See, OA is equal to OD. Why OA is equal to OD? Because their radius. OA is a radius of circle, OD is a radius of circle. So radius of a circle are same always. If you draw any line from any center to any point of the circle, the same. So OA is equal to OD, the radius circle. So same. Second. Then OB is equal to OC. See this OB is equal to OC. Why? Again the radius. They are the radius of the circle. So they should be C. Okay. Then what? If you take angle AOB is equal to angle COD. Why they are equal? Because it is given here. Look at it. It is given here as part of the theorem. Okay. So now what is that we proved is one side is equal, other side is equal, and other angle is equal. It means among the triangles, among the two triangles, one triangle and two triangle, we have two sides equal. Two sides of the left triangle equal to the corresponding two sides of the right triangle. At the same time, we also proved that one of the angle included, okay, are also equal. Okay, AOB is equal to COD is equal. So now what we have is S A S. There is one more congruency rule. Okay, let's see what is that. Then because we proved SSA, we proved that two triangles are congruent. It means triangle AOB is congruent to triangle COD. So by what we are able to conclude this? We are able to conclude two triangles are congruent through the S congruency rule. What is the triangle? SAS rule. Side A angle side rule. Okay. Okay, what is this? Let's also get into the actual theorem of it. Yes, rule says that it's also got to see. Look at side angle side postulate. Okay, in two triangles are congruent. In this case, a triangle AOB and COD, this one and this one, right? Two triangles are congruent if two sides, two sides and the included angle, two sides and the included angle. In my case, this is a side, this is a side, two sides, and this is the included angle of one triangle. In two sides on one, two sides means SAS, right? Side, angle, side. Two sides, one angle of one triangle are equal to the two sides and the included angle of the other triangle. Then we prove that both the circles are congruent. Okay, what is next one is CPCT. All right. So this is the thing. This is how what I proved it. This theory, right? Then by because they are congruent two triangles, I proved that I conclude that AB is equal to CD. What is AB is equal to CD? AB is a one of the side of a triangle. CD is a the side of the other triangle. Okay. Okay. But how did I conclude that AB is equal to CD? The question now, right? We proved. How did we conclude it? We proved that the two triangles are congruent. That means the CPCT rule. The corresponding parts are also equal. So it means what is the corresponding part? This is corresponding to this, correct? This side is corresponding to this side. It means this card is corresponding to this side. And now we proved this is equal to this one by SAS rule or with using the property of congruence of the triangle. Theorem number 2 is now proved. What is the proof? AB is equal to CD. And we used SAS rule, okay, and CPCT concept. Let's start with next theorem. Theorem number 3, 9.3. Okay, what it states, before getting into this, let's visualize this, the circuit. Let's take the help of this circle, a diagram. Okay, so we have a circle and O is the center, and A is a point on the circle, B is a point on the circle. I join 2 points on the circle, it becomes a chord. AB is a chord. Okay, now what I draw is, I draw a perpendicular line from center to the line AB, and we know it meets the chord at M point. Okay, this is the visualization. Let's understand the theorem now. The perpendicular from the center of the circle. So if I draw a perpendicular line from the center to the chord, what is this? It means I'm drawing a perpendicular line from the center to the chord AB. Okay, if I draw a perpendicular line, from the center of the circle to a chord, it bisects the chord. This chord AB is right. AB is now bisected. It means it got divided into two parts of equal length. Okay, it means AM should be equal to MB. But we need to prove that AM is equal to MB. So what is given is OM is perpendicular to AB is given. Okay, let's see that. As usual, we start with data and proof, to prove what to prove and proof of it. Okay. Okay. Now from the visualization, from the diagram, we know O is the center of the circle, and AB is a chord. We know that we join 2 points A and B, it becomes a chord. And OA is a perpendicular to AB. It's given. Okay, you draw a vertical line, perpendicular line from center to the AB. OA is a perpendicular to the AB. It means we know perpendicular line means angle OMB is equal to 90 degree and OMA is equal to 90 degree. Okay. So this is 90 degree. Of course, this is also 90 degree. Totally 180 degree. We know that, right? So because why we draw OM which is perpendicular to AB. Okay. Next. Okay. Then what to prove? We have to prove that this vertical line bisects the chord. It means bisects means cut into two equal parts. Okay, two equal parts means what? What are the part? AM is the one part, MB is the other part. So equal parts means what? AM should be equal to MB. Okay, so we have to prove MA is equal to MB. All right, so let's go for a proof now. Now join two lines, now OA and OB. Now it becomes a two triangles. OMB is a one triangle, OMA is the other triangle. So let me call left as a one triangle and second triangle. Correct? Okay. Now I'm drawing a line here, vertical line here. Okay. So OMA is a left triangle, OMB is a right triangle. Okay. Now look what's happening here. OMA, angle OMA is equal to OMB. Angle OMA is equal to OMB. Why? Why angle OMA is equal to OMB? Angle OM, because we draw perpendicular lines, then we draw. So now it's given to you. Since I'm drawing perpendicular line, it's given that it's 90 degree. Similarly, OMB is equal to 90 degree. OMA is equal to 90 degree. It's given. So we proved angle. One of the angle. We proved one of the angle of the two triangles is equal. Okay, right. Next. Okay, what is next? Next, OA is equal to OB. Why? See, OA is a radius, OB is a radius. Because both of them are radius, they should be equal. So we proved that side is also equal. One of the side is also equal. Angle proved 90 degree. Side is proved because it's a radius side. Okay. Next, go for next topic. Next one. Then OM is equal to OM, because see this OM edge, right? It is common to left triangle as well as right triangle. So naturally it is equal, right? So we proved that this side is also equal. What we proved? One of the angle is equal. Two sides are equal. What is this angle is called? Yes, yes. Correct. Okay. Now what is the takeaway? What is the summary? Two sides and one included angle are equal among the two triangles. Hence, we proved that they are congruent. Congruent by what formula? What rule? By SAS rule. Okay. By what rule? Congruent by what? SAS rule. Okay. Congruent by SAS rule. And we know what is SAS rule, right? Last time we saw it. Okay. Therefore, because they are congruent, the corresponding parts are also equal among the two surfaces. What are the corresponding parts? Now, this is the corresponding part. AM and MB are corresponding parts of the two triangles. Since it is equal, I conclude that the corresponding parts of the congruent triangle CPCT, CPCT, corresponding parts of the two triangles are equal. So I proved that MA is M equal to MB because they are the corresponding parts of two triangles. So we proved it. So this is the sum. This is how we proved theorem number 3. Summary is, if you draw a perpendicular line from the center to the chord AB, this perpendicular line bisects the chord. Okay. Now let's go for theorem number 4. Okay. 4. So what it reads, we'll see it later. Let me go for an visualization of it. Yeah. But before that, again, what is the point here? Remember, theorem number 4 is a converse of the theorem number 3. We already told you. Okay, what is converse of it, right? If you, but yeah, as usual, we go with what is data, what to prove, what is a proof. Okay, yeah, this is the point I was missing. Okay, okay. So what is happening here? Look at this. This is circle, and V is O is a center, and we have a AB as a chord. OM is a perpendicular. It's not a perpendicular, it's a line. That's all. What this theorem says is, if the line drawn through the center of the circle, the line is drawn through the center of the circle. This is center of the circle. Okay. To bisect the chord. Look at this is a chord, right? AB is a chord. What my aim is to bisect the chord. It means AM is equal to MB. It means M is the midpoint of chord AB. What I do is I want to bisect the chord AB, right? Naturally, I'll pick the point midpoint M. Then I draw a line from the center to the midpoint. Okay. So my goal is to bisect the chord, which I measured and identified the point M and draw the line O to M, where M is the midpoint of AB, right? If I do like this, what it does is, okay, it create the line becomes perpendicular to the chord. This line becomes perpendicular to the chord. Look, very similar to the what our theorem number 3, right? The previous theorem, we draw the perpendicular line and prove that it is bisecting. This time we draw a line with a bisection, then we have to prove that the line is perpendicular. Okay, converse of this. Okay. Now, as usual, we start with what is given. AB is a chord. AB is a chord. It's given, right? if is a card is given, right? So then of course center O is joined, center O is joined, so OA and OB it becomes, okay, midpoint. Okay, sorry, from the center I joined a midpoint. What is, I identified the midpoint M, and I joined the center of the circle to the midpoint of the chord AB. Okay, now it's given that AM is equal to AB is part of the theorem. Okay. Hmm. Then what is that? We just joined OA OB to make it triangle. That's all. Hmm. What to prove? What to prove? We have to prove that this OM line is perpendicular to the line AB. This we need to prove. In the proof, let's go for proof. So now observe this. It forms the two triangles. It forms the two triangles. What are these? O. What is this? O M A, one triangle. Then O M B is the other triangle, right? This is triangle one, triangle two. The triangles two. So now let's go to the next one. So what's happening? What's happening in the two triangles? OA is what? OA is part of the left triangle. OA is part of the left triangle, this one, and OB is a part of the right triangle, OBM, right? So OA is equal to OB. This one is equal to this one. Why? Why it is equal? Because the radius of the circles. Because it is the radius of the circles, right? Two radii of the circle. OA is part of the left triangle, OB is a part of the right triangle, but OA and OB both are radii of the triangle. So they actually they should be equal. We proved that. It means one of the side is proven. Side equal among the two triangles. Next, AM is equal to BM. See, AM is equal to BM. Why? It is given. It is given because I identified the midpoint. Then I was able to join the line midpoint M to the O. Right? It is given. This point is equal to this line is equal to this line. Okay. Then it's what is side of it. Right? Why? It's given. Right? AM is equal to BM. Next, go to the next one. Then OM is equal to OM. Why? OM is equal to OM. It's the same point. Common. It's a common, right? It is a common. So this OM line or side is common to both left triangle as well as the right side triangle. So we proved that side is also equal. What theory it is? Yes, yes, yes. So three sides of the left triangle are equal to the corresponding three sides of the right triangle. So we proved that the sides are, the two triangles are congruent. So now triangle OAM, triangle 1 is congruent to triangle 2. It means triangle OMB, triangle OAM is equal to congruent to triangle OBM. We proved it. By what rule? By SSS congruence rule, side congruence rule of the triangles. Okay, we proved it. Then what is the next one? Very important is CPCT. What is CPCT? Corresponding parts of the two triangles should be equal. That's what the CPCT, right? So by that time, what are the corresponding parts? What are the corresponding parts? We proved all sides are corresponding, then the angles should also be corresponding, angles also should be equal, right? We proved corresponding sides are equal, and we by that way we proved triangles are congruent. Now from the, because triangles are congruent, corresponding parts are also equal. It means corresponding, what are parts? Angles and sides, right? This time let's take an angle. What is the corresponding angle here? What is the corresponding angle? This is a corresponding angle. This is a corresponding angle. And what is the this is the one of the angle of the right triangle. The corresponding angle of that is left one, this one. It means OMB and OMA are corresponding angles. It's given. It's yeah, corresponding angles, right? So it means their angles are equal. This angle is equal to this angle. Okay. It means, let me write this as this way: OMA plus OMB, they're equal. Remember, both of them are equal. But what is sum of these angles? This is sine 90 plus 90. Sum of the angles is equal to 180 degree, right? Sum of the angles are 180 degree. Okay. Now because they are equal, let me take as OMA. Okay, OMA plus OMA, 2 times of OMA, right? 2 times of OMA is equal to 180 degree, right? Then what is OMA? OMA is equal to 180 divided by 90. Okay, 90. So that 90 degree means what? Perpendicular line. It means what I proved now is OME is perpendicular to this one. Because I was able to prove that OMA, this triangle is equal to 90 degree. Okay. OMA is equal to what? Is equal to 180 by 2 is equal to 90 degree. Okay. This is how I was able to prove that OM is perpendicular to AB. Okay. This gives 90 degree. Correct. Hmm? Why? We proved, right? We proved OMA is equal to OMB. Right. And this is why CPCT angle. Corresponding angles of the congruent triangle are equal. Right. Done. So, oh, let's say quiz. This quiz is corresponding to the next chapter.